today we're going to be talking about geometric sequences and series. And so I'd just like to refresh a couple things. When we deal with a geometric sequence, we have what's known as a common ratio, R, and a general rule, a sub n equals a sub 1 times r to the n minus 1. So again, instead of a common difference, we have a common ratio, and that would be the value that we consistently multiply by. And we take that value to the n minus 1 power, so that we are always multiplying by 1 for our first term. And that will give us every geometric sequence we have. So let's just test these two sequences and see if they are geometric. From 4 to negative 8, you multiply by negative 2. From negative 8 to 16, you multiply by negative 2. From 16 to negative 32, you multiply by negative 2. So are we always multiplying by the same number? Yes, it is a negative 2. So our ratio is negative 2. So it is geometric. Let's check B out. From 3 to 9, we multiply by 3. Let me get that. From 9 to negative 27, multiply by negative 3. Negative 27 to negative 81, multiply by 3. Negative 81 to 243, multiply by negative 3. So are we multiplying by the same number every single time? No. So we don't have a common ratio, so it is not geometric, since there is no common ratio. Now let's take a look at a sequence. 5 to 2 to 0.8 to 0.32. From 5 to 2, what do we multiply by? If you're not sure, go backwards. 2 divided by 5 would be 2/5, which is 0.4. Is 2 times 0.4 my 0.8? Is 0.8 times 0.4 my 0.32? The answer is yes, so my ratio is 0.4. So it says find the 8th term. Well, to find the 8th term, I need a general rule. So my general rule will be my common ratio of 0.4 raised to the n minus 1 times my first term. And what was my first term? 5. So there's my rule. So if I need the 8th term, I would take 5 times 0.4. 8 is my n, so 8 minus 1, which is 5 times 0.4 to the 7th, which is what decimal? Point 0.08192. So that is the 8th term. Now, it also says to graph the sequence. So under here, I'm just going to put the first term was 5, the second term was 2, the third term was 0.8, the fourth term was 0.32. So my x's, I can go by ones. Just slide this up a little bit so I get my x's. 1, 2, 3, 4, 5, etc. But on my y's, if I go by 1, let's do 1 every other one. 1, 2, 3, 4, 5. So the first term is 5, so I put a point. Second is 2, so 2, 2. Third is 0.8, so it would almost be at 1. Fourth is 0.32, so that would be about right there. Are these making that geometric curve, that exponential curve? And yes, they do make that J curve because I did have an exponent. Okay, now it says one term of the geometric sequence is a sub 4 equals 3. That means the fourth term is 3. So I have to draw myself a little picture. First term, second term, third term, fourth term. Fourth term is 3. The common ratio is 3. So when I use my equation, a sub n will equal the first term times the ratio to the n minus 1. Okay? Well, I don't have the first term, but I have the fourth term. So my fourth term is 3 will equal, I don't have the first term, times my ratio, which was 3, to the n is 4, to the 4 minus 1. So we get 3 equals a sub 1 times 3 cubed. That's 3 equals a sub 1 times 27. So to solve for a sub 1, I need to divide by 27. So I get 1/9 equals a sub 1. So I can take this a sub 1 and plug it into here. I can also take my ratio of 3 and plug it into here to generate my rule. So in the end, I would have the rule is first term 1/9 times the ratio 3 to the n minus 1. And I've generated a rule. Now, if I had plus signs instead of commas here, I would have a series. So let's take a look at how we would solve a geometric series. If we want to add all of them up, you're going to take the first term times the quantity 1 minus r to the n over 1 minus r. This formula is a very important formula to know. The sum of a geometric series is the first term times the quantity 1 minus r to the n divided by 1 minus r. Let's try to apply that. It says, consider the series 4 plus 2 plus 1 plus 1/2, etc., etc. And they are telling us to add up the first 10 terms. So the sum of the terms is a sub 1 times the quantity 1 minus r to the n over 1 minus r. So when we do A, the sum of 10 terms should equal the first term is 4 times 1 minus r. R is my ratio, so let's check what happens from term to term. Times a half, times a half, times a half. So my ratio is 1/2 raised to the n, which was 10. All divided by 1 minus 1/2, which gives me 4 times 1 minus 1/2 to the 10th divided by 1 minus 1/2 is 1/2. I'm going to do this part. 4 divided by 1/2. 4 divided by 1/2 is 8 times, oops, 1 minus 1/2 to the 10th. Now is when you would use your calculator. So let's do the parenthesis part first. You get approximately 7.992. So the sum of the first 10 terms is about 7.992. Now part B has us say, what if I give you the sum? Can you tell me how many terms? So again, using this formula, the sum is equal to the first term, which was 4, times 1 minus the ratio, which was 1/2, to the n, which I'm looking for this time, divided by 1 minus the ratio, which was 1/2. So again, when I simplify this part, I still have my 31/4 equals 4 times 1 minus 1/2 to the n over 1/2. Now I can do this. 4 divided by 1/2 is 8 times 1 minus 1/2 to the nth. Now I would divide both sides by 8. This is already my division bar. So I have 31/32 equals 1 minus 1/2 to the nth. So now I need this nth thing alone, so I subtract 1. So this becomes 32 over 32 negative, plus 31 over 32 is negative 1/32 equals negative 1/2 to the nth. The negative should be a positive. So 1/2 to what power gives you 1/32? In other words, 2 to what power gives you 32? It would be 1/2 to the 5th gives me 1/2 to the nth. So n is 5. Because now my powers would be equal. So the first 5 terms are what's going to add up to 31/4. Now, if this is not where you can write the base as the same base, then you're going to have to use your logs. So we could have taken log of 1/32 and log of 1/2, brought the n to the front. So the log of 1/32 divided by the log of 1/2 still should give me 5. Let's try a couple story problems. You buy a new car for $25,000. The value of the car decreases by 16% each year. First it says write a rule for the average yearly value of the car in dollars in terms of the year, where n is the years. So value of the car is A sub n, and n is the current year. So we know A sub n equals A sub 1 times 1 minus the ratio to the nth. So our first term, initially, what are we spending for the car? $25,000 times 1 minus my ratio. If I am decreasing by 16%, does it make sense why it's 1 minus? 16% is 0.16 raised to the nth. So this becomes 25,000 times 0.84 to the nth. Now that should make sense to you, that you only get 84% of your car value on a yearly basis, because cars do depreciate in value. Now part B says, how many years until the value will be $10,455? How many years? That's n. So that's what I don't know. But I know my value is 10,455. Should equal my equation, 25,000 times 0.84 raised to the n. So again, I have to divide by 25,000. And over here I get 0.4182 equals 0.84 to the nth. Can you ever get 0.4182 to be the same base as 0.84? No, so now is when you need to use your logs. So log both sides. And remember, powers come to the front. So I have the log of 0.4182 equals n times the log of 0.84. So I'm going to divide by the log of 0.84. And I should get my n. And I get n to be about 5 years. Okay, now let's try the next one. You received a job where your salary is $25,000. So your salary is $25,000. By signing your contract, you're guaranteed at least a 6% increase in your salary. If you stay at the organization, how much will you make in your 7th year? Again, this time I'm wondering, what will I have in my 7th year? So I say A sub n has to equal my beginning amount, 25,000, times 1. Am I increasing or decreasing? Increase by 6% raised to the n. But it's going to have to be n minus 1, because in the first year I do not get the increase, so I want this to be a 0 power. So this becomes 25,000 times 1.06, and n is 7 minus 1, which is 25,000 times 1.06 to the 6th. And I get $35,462.98. So after my 7th year on the job, I should make about $35,462.98. Now would be some time for you to practice on your work.